Hi folks, so a couple of years ago, back in early 2023, I was using GitHub Copilot a lot, and its capabilities back then will probably look like the Stone Age compared to all the things it and all the other AI assistant coders do. And so reflecting on my usage of Copilot back then, I wrote a little blog post titled LLMs are compilers. And since then, there have been a few other papers and authors who've also picked up on that theme. I'll leave links to the blog posts and videos and papers below. But today I wanted to talk about one of the most common retorts against that analogy, and that is, but compilers are deterministic and LLMs are probabilistic, they're non-deterministic. And that retort has always struck me as not even wrong. It's talking about a different level of abstraction altogether and just missing the point. So I wrote this blog post that goes into a bit more detail about why that is not a good rebuttal, but I'll make this video to go along with it. The first point is that the analogy really was talking about a big leap up in the level of abstraction that we can program with. Just like compilers let people write their logic in high level languages rather than low level machine code or assembly code, with LLMs, you can now express your intent in natural language. Like Karpathy said, English is the hottest new programming language. So that analogy of LLMs being like compilers wasn't meant to imply that LLMs are behaving exactly like compilers. It was about that jump in abstraction. The second big philosophical point is that if you look at engineering as a whole, all of engineering is basically about taking imperfect, fallible components, imperfect, unreliable components, and then constructing reliable systems out of those imperfect components. That's basically what engineering is all about. So just saying that one of the components is unreliable or non-deterministic is not an argument to say that you can't make useful or reliable systems out of those components. And in the field of computer science, this point was made really well by one of the seminal papers in the field titled End-to-End Arguments for System Design. It is a classic paper and it talks about how you construct end-to-end reliable systems, things like file transfer, but on top of unreliable things like networks failing or disks failing and so on. I've actually made a video about that paper on this channel, so go check it out. I'll leave a link to it. It's a really awesome paper. But anyway, getting back to LLMs. So if you were to build systems with LLMs, there's many ways that you can build things around it to put rails on the entire system. You can start with specs. You can try to build tests, unit tests, functional tests. There are all these ways to wrap an LLM to get more reliable and deterministic behavior in the end-to-end system. And you can also make a comparison with non-AI systems, computing systems of today. If you look at a typical modern computer, there are just so many non-deterministic activities happening on a modern computer, from things like caching or just-in-time compilers or concurrency and multi-threading. There are all these things happening during the execution of a program that are completely non-deterministic and unpredictable. And yet we can build reliable, dependable computers that get the job done. And when using LLMs for code, we are actually blessed with a really great reward function. You can run the code and get feedback from it. You can see if it compiled and ran at all, and if it did, you can check to see if it gave you the answers that you were expecting, going back to unit tests and functional tests. So we shouldn't let this somewhat knee-jerk reaction of, oh, but LLMs are non-deterministic, stop us from building useful systems that use these models in a way that can still give useful and reliable and sometimes even deterministic results if that's what you want. Computers have always dealt with non-deterministic and unreliable components, and we've still managed to build a pretty useful and capable computing stack out of those components. So let's keep doing that. All right, thanks. Bye.